Hey everybody, this is Math 35, College of the Sequoias let's try that again. Math 35, College Algebra at College of the Sequoias. This is section 4 in a review section, and this is where we start hitting into factoring. Many of you might be familiar with it from high school. The diamond method is a common one that people use, the lattice method. I've got a method that's fail-proof that I think you'll like. It tells you when there's no factors, and it's pretty good. Let's get started on, though. This is R4 again, and this is on factoring. And let's talk about the premise of it. Let's just start with something simple. Let's say we have x plus 2 and x minus 5. And those are in parentheses, and we're multiplying together. And recall, we distributed everything from one parentheses to everything in the other. So if I have the x in the first parentheses, multiply to that, we get an x squared. And x times negative 5 is negative 5x. And I could do the same thing with the second term. The 2 times the x is plus 2x. And 2 times the negative 5 is negative 10x. Then I've got like terms, and I can add them together. I can combine the negative 5x and positive 2x. And we get negative 3x minus 10. So here we distributed. Factoring is the reverse of distributing. So we can start with the x squared minus 3x minus 10. Break it up into the negative 5x and the 2x there, split that negative 3x up, and from there get to the parentheses. And I'm going to show you the process of doing it. There's a shortcut method when the number in front of x squared is 1. I'm going to do that last because it only works when it's 1. I think we should go the distance. And so let's just start with something smaller. Let's start smaller. We're going to start off with 6x squared minus 18x to the 4th power. This is how I like to do it. I want to factor everything. I'm going to make a table. So I'm going to factor my 6x squared. And I'm also going to do the 18x to the 4th. And I'm just going to make a note that there's a negative sign. So what multiplies to make 6? 6 is 2 times 3. And I'm going to do the other numbers now, too. I like to do the numbers together. 18 is 2 times 9. But 9 is not broken all the way down into prime numbers. So let's break 9 down. 9 is 3 times 3. And I'm going to line up the numbers so that they're underneath matching numbers. I want everything that's vertically aligned to be the same number. I need another column for 3s. Then I'm going to go with the x's. The x squared has an x and an x. And the x to the 4th has 4 x's. Now, normally I wouldn't do this many x's. I would write x squared, but I think to start off with, it's handy to show you should factor everything down to its prime versions. What I'm going to do then is I'm going to look for the greatest common factor. The greatest common factor is frequently abbreviated. In fact, I don't know of any other one, GCF. So the GCF is everything with a completely filled column. So I've got 2's. So I'll have a 2 in my GCF. The 3 column is completely filled, so I'll have a 3. This 3 is not completely filled, so we won't have it. And then we'll have these 2 x's. And then you take them and you multiply them together. And when I do that, 2 times 3 is 6, and x times x is x squared. The GCF is 6x squared. If you do this table, it's kind of handy, because what's left behind is what stays in parentheses. What I'm going to do with this, so let me write that down. What's left over goes in parentheses. And if nothing is left in a row, there's a 1. Use a 1. And so what we do is we take our GCF and we write it on the outside. So my GCF was 6x squared. Let me rewrite this, the whole thing that we had, the problem that we're looking at. And what I'm going to do is I'm going to take my GCF and I'm going to write it on the outside. And whatever I have left over goes in parentheses. I've got nothing in the top row, so I'm going to put a 1. And then I'm going to use the minus sign. The sign's got to be in there. And then I've got a 3 and x and an x. So 3 times x is x squared. And that's how that works. So I'll pause for a second. We can always verify this to make sure it works. And it's a good idea to do so until you're really good at factoring. You should always multiply it back out and see if you got the right value. Please pause it if you need longer. So I had 6x squared minus 18x to the 4th equals 6x squared times 1 minus 3x squared. Now what I'm going to do to confirm that it's correct is let's just distribute. 6 times x squared, or 6x squared times 1 is 6x squared. And 6x squared times negative 3x squared. I've got 6 times negative 3 is negative 18. And x squared times x squared, I add the exponents, 2 plus 2 is 4. So x to the 4th. And notice we have back what we started with. So that's what I meant by checking it, and it's fairly straightforward to do. If you're not comfortable doing that, another approach to figuring out what's left inside, if you don't like the what's left inside method, is once you have the GCF, we can do the following. You still want to put it on the outside, but then take what you started with and divide each of them by the GCF, whatever you factored out. Notice if I redistribute it, if I multiply it back in, the 6x squareds cancel and I'm back to where I started. So that works. But here I can see 6's cancel, leave behind a 1. X squareds cross each other off, leaves behind a 1. And then I've got 18 divided by 6 is 3. And when we divided exponentials, we subtract the exponents. So 4 minus 2 is 2. So we have an x squared. And notice that's up here. This is gets the same result as using that thing I did with the table right here, underlying method. This table is going to help us with something else. If we use the table, it also helps with the least common multiple. And we're going to be using that too. So that's always handy. So the it's a twofer. If you start working with it now, it's worth trying. So let's do another one. I want to make sure you're comfortable with seeing how this table works. Let's do 4x to the 4th minus 6x squared. And I'll write both of them down. And I'm going to factor both. 4 is 2 times 2. 6 is 2 times 3. I already have a column for the 2, so I'll put it there. I don't have a column for the 3, so I'm going to make a new column for the 3. Notice I'm not putting the 3 underneath the 2. I want everything to be vertically aligned so that all the columns just have the same number in them. And now, rather than doing each x individually, what I'm going to do is I'm going to look for the one with the smallest exponent, and that's that one. So I'm going to put x squared. This one has an x squared, and then also to get an x to the 4th, I need another x squared. My GCF will be my completely filled columns. So it will have a 2 and an x squared. So 2x squared. We'll put that on the outside. I'm going to have a minus in the middle. And then I go in and I go, okay, let's see. This has a 2 left and an x squared. So the 4x squared should leave behind a 2x squared. And the 6x squared just has a 3, so it's going to leave behind a 3. If you're throwing it on a computer to speed it up, you shouldn't. But like on a factor calculator on a computer, let's face it, when you get into calculus, sometimes it just is much faster to throw it into a calculator. You should know how to do it by hand, though. And you need to do it by hand for the test. I don't want you to cheat on the test. So in a calculator online, what you'll put is 4x and then a caret sign 4 minus 6x caret sign 2. That's how this is the key, how you key it in. This is also a shortcut in MATLAB. A shortcut for exponent signs. Is using that caret, and where you can find it is hold down shift and then hit 6. Shift plus 6. Okay. And it doesn't have to be simple. It can be more challenging. So let's kick it up a notch. Bernie's back in here because she don't like Mondays. Sorry, I got the chicks in my head. They got a new song called March, March. I like it. 14x cubed y squared minus 28x squared y cubed plus 21x squared y squared. Just to make it challenging, and it works. You'll see that it works. So what I'm gonna do is I'm gonna write down each term, and I'm gonna make sure I leave myself some room. There's a lot of letters here and numbers, so I'm gonna move it a little bit more to the left. And I know my result should have, the GCF is out here, and then I'll have a minus and a plus. And let's just go through and factor them. Let's do the numbers first. I like keeping the numbers together. 14 is 2 times 7. 28 is 4 times 7. I have a column for the 7 already. I'll put the 7 there. 4 breaks down some more. 4 is 2 times 2. Got a column for a 2. I'll put it there. I don't have a column for the other 2. I'll make a new column for the other 2. 21 is 7 times 3. I've got a column for the 7. I'll put it there. And I don't have a column for the 3, so I'll make a new column for the 3s. Now I'll look at the x's. The one that has the smallest power, the smallest exponent is x squared. So I'll use that. Each of these have an x squared in them. And it looks like the top one has an extra x. And then I look at the y's. The smallest exponent on the y's is a square, y squared. So I'm going to put a y squared down. Each of them has a y squared in it. And the middle one is y cubed, so it needs another y. Why does it need another y? Multiply the y squared and the y back together, and you'll see that that's y cubed. That's what I'm doing there. All right. So my GCF, completely filled columns, I need a 7. I need an x squared, and I need a y squared. I'll throw a circle around them. It makes it a little bit easier to see what's needs to go in the parentheses. So my GCF is going to be 7x squared, y squared. And then the top row, the first item, 14x cubed y squared, it's left behind a 2 and an x. So I'll put a 2x there. 28x squared y cubed is left behind a 2 and a 2, that's a 4, and then a y, so 4y. And then 21x squared y squared, the only thing left in that row is a 3. So apparently that's what that factors to. Okay. Now let's take a look at what we started with. What was the example I led with? First thing we had in this chapter, we had x plus 2 times x minus 5. And when we multiplied it all out, we had x cubed, x squared minus 3x minus 10. How can I go from there to there? Well, what I want you to do is get used to this form. They use it a lot in college algebra, and I'm going to use it a lot because it's just easy to do. This correlates to ax squared plus bx plus c. So a equals 1, b equals -3, c equals -10. Notice I'm just matching up the numbers in front. And when there's no number, I put a 1. Okay? Now, what I want to do is I want to make a table. I'm going to do a times c in one column. What is a times c? A times c is -10. And I'm going to put b in another column. B is -3. We want numbers that multiply to a times c and add to b. This correlates to the diamond method approach. However, the diamond method approach is very much guess and check the whole way. And if you don't guess the right numbers, you may think it doesn't factor. What I'm going to do is I'm going to go through the factors of -10, and I'm going to write this down systematically. Write factors of a times c down in a systematic order. So what I'm going to do, we can always use 1 in the number, right? Always can use 1 in the number. So I can do 1 times -10. What else multiplies to make 10? 2 and 5 does. So I could do 2 times -5. Does 3 go into 10? Nope. Does 4 go into 10? Nope. And I could keep going down the list. 5 does. We would leave behind a -2. And then 10 times -1. Then add these up. So add. 1 plus -10 is -9. 2 plus -5 is -3. 5 plus -2 is +3. 10 plus -1 is 9. Now, I would have stopped. What you're looking for is when you get B in this column. That's this row right here. That matches my B. So let's use that. So what I'm going to do is I had x squared minus 3x minus 10. And we're going to take the factors that work and break up the bx into those. And what I mean by that is I'm going to take the -3x and I'm going to break it up. We had 2 and -5. I'm going to break it up into +2x and -5x. So this is in red on the left. And I'm going to bring my x squared down untouched and my -10 down untouched. Finally, we look for break into pairs or split into pairs. Find GCF in each pair. So I'm going to do that pair and that pair. What does x squared and 2x have in common? If you make the table, you're going to see that you only have an x in common. And that's going to leave behind x plus 2. If we do -5x and -10, they both have a negative. And they both have 5 in them. And if I leave, what's left behind is I have an x still. And if I divide -10 by -5, I get +2. If you want to see the table real quick, let's do the table real quick. X squared and 2x, and then -5x and -10. This is x times x, and this is 2 times x. I'll put the 2 in a new column and an x. That's the only great common factor there. That's the one that goes out front. These both have a -5. And this one's times 2 to get -10. This one's got an x. That's my GCF there. So GCF, GCF. And you'll notice if you've done this, if you factor this correctly, if you have the right factors up here, we should have x and 2 left behind in both. These parentheses should be identical. When they are, we pull them out. So I'm going to pull this out, put it out front. And what do I have left over? My GCFs make another parentheses, x and -5. And you'll notice x plus 2, x minus 5, x plus 2, x minus 5. So when we started with this and we multiplied it out and got that. Now we can see that it goes backwards, okay? The reason why I recommend this table method, let me show you something, and I'll point it out repeatedly in the following examples. Notice that it's very systematic. I'm going down the list until I'm out of numbers. I would normally, when I'm doing it, stop and add them up as I'm going and see where I'm going. The other thing I want you to notice is that if you do this in an ordered manner, like I did, 1, 2, 3, 4, 5, I stopped writing down the ones that aren't factors, but if I keep it organized and always going up, notice this list is always going up. -9 is lower than -3, -3 is lower than 3, 3 is lower than 9. So this will always rise, which means if you pass up B on the list while adding, it doesn't factor. Okay? And I will actually give examples today that won't factor, but we won't know when we start. This is very similar to the diamond method, but the diamond method only works when the numbers are easy. I promise you, I've used the diamond method. That's how I learned algebra at first. I don't think that was a very good way to teach it, because learning how to do the easy way makes the hard way really, really hard. If you learn the harder way first, everything is gravy at that point. And it's not really that hard. Write down a systematic list and find what you need. Okay? Let's kick it up a notch. Let's try something harder. I'm going to need a new page. Let's try something harder, and I'm going to show you why I use this. So new page. I'm going to use z's this time. Why not? 5z squared plus 4z minus 12. So if I treat this as like ax squared plus bx plus c. My a is that number, 5. B is the number in front of z, that's 4. And c is that number, -12. It has to be in the right order. If they're not written in the correct order, if like the x squared's at the end, you should change the order up. That way they're in the correct order. We want descending or decreasing order by exponent. All right, so let's make my little table. I want a times c. A times c is -60. And b equals 4. Those are the values I'm looking for, -60 and 4. All right. Now, pro tip. If this ends up being negative, and this sign, if this ends up being negative, one of the numbers that multiplies to make it is going to be negative, and one of the numbers that multiplies to make it is going to be positive. When you add them up together, whichever number is bigger should have that sign over here. So note B is positive. And A times C is negative or less than 0, which means bigger factor will be positive. And if that doesn't make sense, just stop and think about it, and you'll see on the list while we're going through it what happens. So we have two numbers and they add together. If the bigger one's negative, like -10 and +4, we add them together, we get -6. B would be negative. So we want the bigger number to be positive. So rather than doing 1 and -60, I'm going to start with -1 times 60. That adds up to 59. Then I'll increment that by 1, -2. Does this work? You can get these numbers really quickly in a calculator. Oops, bumped my camera. Just if you're checking the number, take the number in the calculator and divide by it. 60 divided by 2 is 30. That adds up to 28. That doesn't match my B. I'll try -3. 60. Just do the number without the sign and put the sign in. -3 times 20. That adds up to 17. Does 60 divided by 4? 4 times 15. This adds up to 11. -5. -6. And I'm going to illustrate -10. We can keep doing. I know these divide in. Note that 60 divided by 7 gives a decimal, so I won't have it. 60 divided by 8 gives a decimal. I won't put it in there. These other ones work though. 60 divided by 5 is 12. 60 divided by 6 is 10. And notice these numbers are 10, so this one should be 6. I went farther than I needed to, and I did it for a reason. I want to show you what happens. -5 and 12, we add them together is 7. -6 and 10 together is 4. That's the one we want. That's the one we want. And -10 and 6 is -4. Notice these all go the same direction, decreasing. Okay? They're going to go one direction. If you start with 1, 2, positive 1, 2, 3, 4, they go up. If you start with -1, -2, -3, -4, they go down. Okay? Note that since they go down, if you're way off from the number, like we wanted a 4 and we were at 59, maybe I would skip checking -2, -3, -4, jump down to -5 or -6, see if it happens. And I'll show that on the problem and what I mean by doing that. But you can speed up this process. So these were my numbers, -6 and 10. So what I'm going to do is I'll copy down my 5z squared, and I'll copy down my -12. I'm going to split 4z into 2 parts, a -6z and a 10z. Okay. Now we're going to break it up into groups. Let's do our little tables. I want that to be one group and that to be one group. So 5z squared and 6z. 5 is just 5 and 6 is 2 times 3. They don't have any numbers in common. And then we have a z times z. And this one has a z. The GCF in this column is just a z. So a z will come outside and it leaves behind a 5z. And this was a -6z, so we're going to have a -6 left over. And I'm just pulling those 5z and 6 from here. Whatever's left over on my chart. I'll do the same thing with 10z and -12. Note, I should end up with 5z minus 6 again. I should get that. So 10 is 2 times 5. 12 is 2 times 6. And I know when I break down 6 to 2 times 3, it's not going to have anything in common with a 5. So I'm going to leave it as a 6 for now. Until you're comfortable recognizing things don't match up, you should factor it all the way down. And then this one has a z and the bottom one doesn't. The GCF here is a 2. So I should have a 2 plus 2. And whatever I have left over goes in parentheses. Again, 5z, and then we've got a minus and a 6. My GCF goes in one parentheses, z plus 2, and the repeating parentheses makes another parentheses, 5z minus 6. That's what 5z squared plus 4z minus 12 factors into. We can check. Let's check it. So that's the answer. That's the factored form. So let's check it by redistributing. So z plus 2 times 5z minus 6. If I distribute the z, I've got z times 5z is 5z squared. Z times negative 6 is negative 6z. 2 times 5z is 10z. And 2 times negative 6 is negative 12. Finally, we combine like terms. 5z squared stays by itself. Negative 6z plus 10z is plus 4z. And then we got negative 12. It's got no common factor, so we put it together. And notice that's what we started with. So it worked. Good thing about a lot of mathematics, you can always verify your work. If you get it when you try, if you do check it, and you should, if you check your work and it doesn't get what you expect it to get, you made a mistake. Go back and find the mistake. Do not just try to force the numbers to work. If they don't do it right, you clearly made a mistake. Just look for the mistake. Don't just leave it and pretend like it's not there. Find it. So that's how this process works. Let's kick it up a notch. Let's kick it up a notch. Do some other stuff with it. So I want to point out, if you can, always look or always factor out a GCF if it exists. For example, let's do just a quick example. This is that's a must. If you don't do it, you won't factor it all the way. You're going to get it wrong. So let's try 16x cubed plus 12x squared plus 20x minus 4. You can tell right away whether or not there's going to be an x in the GCF. Does this negative 4 have an x? No. This one doesn't have an x, so the GCF cannot have an x. If there's a constant in the problem, GCF will not have an x. X or variable, whatever the letter is, if it exists. So we're going to look for, let's factor the numbers. We got 16, 12, 20, and 4. Now, I didn't do them earlier, but you might like this. Make a little tree. So these are called factorization trees. Let's start with 16. Pick two numbers that multiply, make 16. 4 times 4 works. So I'm going to do 4 times 4. I'm going to make little leaves coming off this tree. And then if a number is prime, which means it can't be factored further, circle it. If it's not prime, keep factoring it. So 4 is not prime. We're going to keep factoring it. 4 is 2 times 2. 2 is prime. So I'm going to put circles on them. And that means this 4 factors into 2 times 2. 16 is apparently 2 times 2 times 2 times 2. I'll do the same thing with the 12. 12 is 4 times 3. 3 is prime. 4 is 2 times 2, and those are prime. So 12 is 2 times 2 times 3. I'll stack up 2's. I'll make a new column for 3's. The 20 is 4 times 5, and 4 factors to 2 times 2. So I should, and 5 is prime. So I'll have another 2, put those underneath the other ones. And we'll make a new column for 5. And 4, we've already got listed. It's 2 times 2. So my GCF looks like it's 2 times 2 or 4. So I'll factor it out. I'll put a 4 out front. The 16 leaves behind 2 times 2, which is 4. And it has an x cubed. So I'll put the x cubed. 12 left behind a 3. So I'll put plus 3. It's positive 3, so I'll put plus 3. And it had an x squared with it. You can put the x's over here on the tables, but you'll see that it doesn't have a common factor. So save yourself some work. 20 left behind a 5. And it was 20x, so it'll be 5x. And then we had negative 4. It's going to be negative. Nothing here, so use a 1. When the row is empty, use a 1. And there we go. You could try factoring this further, and we'll do this on a problem later on where it does factor further. But this one, it doesn't. I just wanted to show you that. Ready for more? Okay. So let's just say that. Step 1, GCF. Factor out GCF if it exists. And step 2, try to factor what remains. All right. Let's do some more. Let's try 36x to the 5th minus 18x to the 4th plus 54x cubed. Look for a GCF first, so let's factor these. Whenever I see big numbers in front, I try to move my thing to the left more because I'm going to need more room for numbers. So let's just get to our factoring. 36, I know from the times table, we got 2 options. We could do 4 times 9 or 6 times 6. I like 6 times 6 because once I factor 1, I just double it. 6 factors to 2 times 3. And that means that's 2 times 3. And those are my leads. So I've got 2 2's and 2 3's. I'll do the 18 now. 18 is 3 times 6. And 6 is 2 times 3. I got 1 2. I'll put it in the column for the 2. And then I've got 2 3's. I'll put that in the column for the 3's. And then 54. is 6 times 9. And these factor more. 6 is 2 times 3, and 9 is 3 times 3. So I need 1, 2, I need a 3, another 3, and then a third 3. So my GCF will have a 2, a 3, and a 3 in it. And now we look at our x's, pick the one that has the lowest power or exponent. The one that's lowest, if you've done them in descending order, it should be the one on bottom, x cubed, which means they all have an x cubed. And that will be part of our GCF. And what do I need to multiply x cubed by to get x to the 4th? I need another x. And x to the 5th needs 2 more x's, so x and x. So my GCF is 2 times 3 times 3 is 18, and x cubed. So if I didn't do the table, I recognize, for me, I recognize right away these were all divisible by 6. But 6 was not the greatest common factor. I did not recognize they were all divisible by 18. And so if I had just tried to factor out a 6, it would not have been completely factored. Having done that, let's show what it factors to. We've got our 18x cubed. And what does that leave behind? I've got 2 times x is 2x squared. And in the middle row, I've got a minus sign, so minus just an x here, right? Minus x. The next one is a plus, and all I've got here is a 3. So that's what that factors to. Rewriting it down here like I should have done in the first place. Now that I've done the GCF, that's step 1. I'm going to try to factor this. Try to factor that. So if I line this up with ax squared plus bx plus c, a lines up with positive 2, b lines up with negative 1, c lines up with 6. C lines up with 3. Look at me. I'm jumping ahead. I was doing a times c in my head. A times c is 6, and b is negative 1. Factors that make 6 are 1 and 6, 2 and 3. And if I put 3 and 2, it's just the same thing. Or I could do negative 1, negative 6. Let me show you what I meant by the table, where it skips it. So a times c is 6, and b equals negative 1. Let's see. So factors that make up a times c, I could, let's start with the lowest one. We could do negative 6 times 1, or negative 1. I could do negative 3 times negative 2. I could do negative 2 times negative 3. And these are repeating. I don't need that, so I don't need those. I could do 2 times 3 and 1 times 6. Actually, this one is not a good one to show you the gap thing I was talking about. B equals negative 1. This adds up to negative 7. This adds up to -5. This one adds up to 5. Actually, it is a good one to show. And this one adds up to 7. B equals -1 is not on the list. It's in fact, it's between these two. So it doesn't work. So this does not factor further. So 18x cubed times 2x squared minus x plus 3 was the last answer. That's all it could be. Let me give you guys one to try. Let's do 15x squared. Well, no, let's do x cubed. 15x cubed minus 21x to the 4th plus 6x squared. So that's a 3. I suggest you rewrite this in descending order. The biggest exponent is x to the 4th. Then x cubed. Then 6x squared. Okay, so I'm going to assume you paused and worked on it. Let's see what we got. 15x, negative 21x to the 4th, 15x cubed, 6x squared. This is 3 times 7. 15 is 3 times 5. And 6 is 3 times 2. They all have an x squared. And that needs another x, and that needs another 2 x's. The GCF is, we got a 3 and an x squared. So I'll put a 3x squared out front. And what does that leave behind? It leaves behind a 7x squared, which is negative. So I got to put a negative there. 15x cubed leaves behind a 5x, so plus 5x. And 6x squared leaves behind a 2, so plus 2. I really don't like having that first thing there negative. When I want to check to see if it factors, it bothers me. This bothers me. That negative there bothers me. So what I'm going to do is I'm going to factor the negative out. Factor a -1 out. And the result is just change the signs. So I'll make this negative 3x squared. I'll put the negative on the outside. And that just results in changing all the signs on the inside. Now I want to see if this factors further. Let's check it. A times C is -14. Then we got A, B, and C. B is -5. I've got two numbers that multiply to make a negative number. The bigger number has to be negative because B is negative. So 1 times -14, 2 times -7. This adds up to -13. This adds up to -5. Ooh. That's what I'm looking for, right? -5. So don't forget this -3x squared. It comes down. And then I've got 7x squared and -2 on the inside of this. The -5x splits up into -7x and 2x. keep bringing down that negative 3x squared. You'll forget about it if you don't. We do some grouping. I'm going to use brackets right now because I'm going to have parentheses again. Out of this first set, it looks like a 7 comes out of both, right? And they both have an x, so let's pull out an x. That should leave behind an x minus 1. If I did this correctly, an x minus 1 will appear again. And what do I have to factor out of 2x minus 2 to get that? Well, if I want to go from 2x to x, I need to have a plus 2 there. Since I didn't do the factoring the normal way, I'm just going to re-verify. I'm going to check it, multiply it back out, make sure it works. 2 times x is 2x, that's good. 2 times negative 2 is negative 2, that's good. I've got my negative 3x squared on the outside. Don't forget to keep bringing that down. I've got my repeated parentheses, x minus 1. And then I had what we factored out, the GCF, 7x plus 2. Apparently, what I started out with, negative 21x to the 4th plus 15x cubed plus 6x squared, factors all the way down to this. Okay? Let's see. That's really the gist of what we're doing. Let's see if we've got more that. Oh, I gotta show you what happens when we have one that skips. So something that doesn't factor. So let's do 3x squared minus 15x plus 16. I've got a equals 3. It's the number in front of x squared. B equals negative 15. C is 16. So a times c is 48. And b is negative 15. Now let's think about this. I've got two numbers that multiply together to make a positive number. This means when you have this, when a times c is greater than 0, like it is now, 48 is greater than 0, both factors are negative or positive, or both are positive. You can't have one of each. Okay? If you have one of each, they multiply to a negative number. And so at this point, B, use the sign of B to decide. B is negative, which means the factors have to be negative, because there's no way two positive numbers add up to make a negative number. So let's use negative numbers. Let's be systematic. I'm going to do negative 1 times negative 48. Those add up to negative 49. I'll just keep going up. Does 48 divide by 2? Yes, it does. So negative 2 and negative 24 is negative 26. This isn't working. I'm still a long ways from 15. 48 on the times table has a 6, so let's jump up to negative 6. Negative 6 times negative 8. 6 times 8 is 48, so negative 6 times negative 8 is negative 48. That's negative 14. And this is how you can speed it up when it's a big number. If you're far away from the number, jump ahead. Negative 14, I've actually gone past negative 15, so I'm going to try to go backwards. Negative 5, does that divide in? 48 divided by 5 is a note. That's a decimal, so that doesn't work. Apparently, we'll try -4 is 12. -4 and -12 makes -16. I could do -3, but I want you to notice something. We have that systematic order. We skipped -15. If you wanted to show it out, include the -3. You should have -16, which will give you -19 added up. Going systematically, 1, 2, 3, 4, 5 didn't work, 6. The numbers kept decreasing, but we skipped -15. We skipped B in the systematic approach, or orderly approach, which means this does not factor further. I say further because if you had pulled out a GCF, at least it factors once with the GCF. This doesn't factor further. Some people put different things. They'll say does not factor. Like if we were to do this live in class, I would accept does not factor. If you're lazy like me, DNF. And the technical math jargon is this is prime. When something is prime, it cannot be factored. Okay. Another one that they'll try to show you, they'll try to throw some tricky shit at you. So let's do the tricky shit here so you know what's coming. Let's go with 49x squared plus 28xy plus 4y squared. We've got two variables here, x and y. Now, if I look at it, I've got an x squared here, a y squared here, something in the middle with an xy. It looks like I might have, when I do it in parentheses, I might have an x and a y in both things. And maybe, I don't know what goes in front here, I don't know what goes there, I don't know what goes here, I don't know what goes here, and I don't even know the sign. Question mark on the sign. Plus or minus, who knows? So this is what I like to do. I don't know if you will. Let's pretend the y isn't there. And make sure to add it back in at the end. So I'm going to do 49x squared plus 28x plus 4. And when I mean add it back in at the end, it will go at the end in the parentheses. We'll see that. So, what do we got here? We got A is 49, B is 28, C is 4. A is 49 is 7 times 7. C is 2 times 2. They don't have any numbers in common. So there is not going to be a GCF. Okay. A times C, 49 times 4. is 196 and B equals 28. So it adds to a positive number, and 196 is positive. They have to both be positive. So 1 times 196, that adds up to 197. We are a long ways from 28. So I'm going to try to skip some numbers. I don't need to do some numbers that are close. Let's jump to using the ones we had. A times C is 4 times 49. That's 53. That doesn't work. So what other factors we have here? Let's see. Does 5 divide into this? No. We're getting close to 28, so I'm going to go slower. Does 5 work? 196 divided by 5. Nope. Decimal. 196 divided by 6. That's a decimal. 196 divided by 7. That's a number. So 5 is out, 6 is out. 7 gives me 28 left over. And I just did it in the calculator and I found it really quick. 7 plus 28 is 35. We're getting close. Start checking them all. 8, 9. Nope. 196 divided by 9. Nope. 196 divided by 10 doesn't end in a 0, so 10's out. 11 doesn't work. Oops. That's a decimal. We can check 12. That's a decimal, so 12 is out. Check 13. 13's a decimal, it's out. Check 14. 196 divided by 14 is 14. So 14 times 14 is a factorization of 196. Those add up to 28, and that's what we're looking for. I skipped 2 and 3 because I was far away from B. So if you skip ahead and you happen to go past it, notice this is still decreasing the whole way. If you skip ahead and you go past it, you got to go backwards. It's somewhere in the middle. So let's factor this. We've got 14 and 14 is my factoring. So I've got 49x squared plus 4 at the end, and this is 14x and 14x. Break this up into pairs. If you go through the table thing, or if you get better at factoring and noticing, looking for the greatest common factor now, it looks like a 7x comes out of both of those. And it should leave behind a 7x plus 2. My 7x plus 2 should repeat. And I got to multiply by 2 here to get that. If I finish factoring, 7x plus 2. And what's left over gets its parentheses, 7x plus 2. And now add the y back in. So we got 7x plus 2y. We'll put the y in there. 7x plus 2y. I encourage you to multiply that back out and verify that it gets what we had on top. 49x squared plus 28xy plus 4y squared. I also want you to note that when these terms repeat, we can write this as 7x plus 2y squared. Whether MATLAB demands it or not, to get homework assignment, I'm not sure. Sometimes it will say what I want, sometimes they'll take either thing. So you should verify you get 49x squared plus 28xy plus 4y squared when you multiply that back out. All right. Okay, so now this is really, that's about as difficult as it gets. Okay, that's about as difficult as it gets. Where's this shortcut? Why is this so much harder than what they taught in high school? Well, what they taught in high school, they gave you the Care Bear approach. They gave you the I don't think you're smart approach. I don't think you can do this approach. I know you can. You're a college student. You're smart. You can do this. Just takes a little. It takes more effort. You can do this. Let's show the shorter approach that is useful, that you probably learned first when factoring, but doesn't always work. This method will work no matter what. If it factors, it factors. If it doesn't factor, you'll skip the number and it doesn't appear and you know it doesn't factor. So when we have ax squared plus bx plus c, we have something in that form when we're done. And if a equals 1, you really have something like x squared plus bx plus c. There's a shortcut in the work. I'm going to work it out. I'm going to do one. I'm going to work it out the way I did, and I'll show you where the shortcut, where it shows up. So let's take a look at one that has an a equals 1, like x squared plus 5x plus 6. So a equals 1, b equals 5, c equals 6. So a times c is 1 times 6 is 6, and b is 5. I've only got 2 combinations to end up with 6. 1 times 6, 2 times 3, that's 7, that's 5. We want the 2 times 3. So the 5x splits up into plus 2x and plus 3x. Bring my x squared and my 6 down. And we factor by grouping these. Only an x can come out of the first one. We have x plus 2. My x plus 2 should repeat. And I see both 3 and 6 are divisible by 3. So we pull out a 3. And I've got plus 3 and plus 2. You can verify it. 3 times x is 3x. 3 times 2 is 6. We'll factor out our x plus 2 because it's a common factor there. And whatever's left over gets its own parentheses, x plus 3. That's what x squared plus 5x plus 6 factors to. The shortcut bypasses the splitting. Shortcut bypasses the splitting. If a equals 1, whatever your factors are, go at the end of the parentheses. If a equals 1, I can do x, and then I'm going to grab these and I'm just going to put them in. Positive 2, positive 3. And note, that's what you get when you do split them up by grouping and do the factoring. So this is one of the first ones they teach in high school generally, or at least it was for me, and it's the easiest one. But it only works if A equals 1. If A doesn't equal 1, this doesn't work. So let's comment on that. Shortcut doesn't work if A does not equal 1. The other method I showed you works every time. Let me give you guys one to try real quick. Why don't we do x squared minus 2x minus 15. Pause the video and work it out. Okay. A is 1, B is -2, C is -15. A times C is -15, B equals -2. One's negative, one's positive because A times C is negative. B is negative, which means the bigger number is negative. So let's try 1 and -15. That adds up to -14. That's no good. 2 does not go in. 3 goes in, -5. That adds up to -2. That's what we're looking for. The shortcut, we can just drop it directly in. We'll put an x in front of both, and we'll flop in a +3 and a -5. So that's the shortcut. And for just for showing and working it out, we've done it the other way. This is +3x minus 5x. And we still have our x squared minus 15. We factor by grouping. This is x times x plus 3. I need the x plus 3 again. And to get -5x, I got to multiply x by -5. And I pull out my common terms. X plus 3 leaves behind x minus 5. So it worked. Now, something I didn't answer, and you might have had a question. At some point in last semester, this is where students ask a question. What if I put the -5 first? What if I do x squared, then -5x plus 3x? Does that change it? What if I put the -5 before the 3? Well, let's keep working this one out. We split that up by grouping. We get x times x minus 5. The x minus 5 hopefully repeats. If it does, let's check it. What multiplies to make, what do I got to multiply x by to get 3x? I need to multiply x by +3 to get 3x. I'll distribute that 3. 3 times x gives me 3x. 3 times -5 gives me -15. That's correct. I can pull out the x minus 5. And that leaves behind an x and a +3. And that's factored. Are these the same? So this goes back to that commutative rule, commutative property. A times B equals B times A. X plus 3 times x minus 5. That's like A and B. That's the same thing as x minus 5 times x plus 3. If you multiply them both out, you get x squared minus 2x minus 15. So what if we have 4 terms? Can we do something with 4 terms? I've been doing 3 terms here. Can we do something with 4? Let's give it a check. 4 terms means if they're different, we're going to have a constant, we're going to have x to the first, we're going to have x to the second power. To get a 4th term, we need an x cubed. What about 4 terms? So we'll have a constant. This is what I said verbally. I'm writing it down. X squared, x cubed, or a different letter. (9x cubed minus 15y squared plus 6y minus 10. Oh, x's. Let's make these x's. That's what I meant to do. You know what? I'm going to just write that line over. That pin's starting to die. Toss it. All right, so with 4 terms, do grouping. Then GCF. So I'm going to try grouping these 2 together. And I do want to make a note. If the first grouping doesn't help, switch some things up. Switch middle 2. And I'll show you both scenarios here. Switch middle 2. Okay. I'm going to pause. I want you to go ahead and factor those. See what you come up with. And I told you what to do, and I know you can do this. This isn't really a whole lot different than what we did before. I just added an extra x cubed in there. But we've been doing 4 terms in our trinomial factoring. Okay. If you did this, 9 and 15 are both divisible by 3. And x squared is the lowest exponent, so we'll pull out an x squared. This should leave behind a 3x and a negative 5. And both 6 and 10 are, 6 is 2 times 3. 10 is 2 times 5. Only a 2 comes out. That's going to leave behind the 3 and the 5, and the 5 is negative because of that. That sign right there. And look, we've got a 3x minus 5 in both. When that occurs, we can pull it out. And whatever's left behind goes in parentheses. If there is a square or bigger, is an exponent of 2 or more, or greater than 2, greater than or equal to 2, try to factor more. So try to factor that one, because it's got an x squared. You'll find that it doesn't factor. 2 is a prime number, and it does not divide into 3x squared, so that's done. Sometimes, so let's illustrate the switching it up. Sometimes switching helps. Do I have an example if it doesn't work well the first way? Yeah, there we go. 4m squared minus n squared plus 4n minus m squared n. If I do this, nothing in common here in the first set. So I'm going to change it up. I'm going to switch them around. Let's say I have an m squared here. Let's put the thing that has an m squared with it. Does that make sense? 4m squared, let's match the n squared up with it. Let's put the negative m squared there. And that leaves behind negative n squared plus 4n. So if I pull out the common factor here, it's m squared, right? And that's going to leave behind a 4 minus n. It looks like maybe if I want to have the 4 in front, I need a 4 minus n if this works. If it works. So let's switch the order there. I'm going to take the negative n squared plus 4n, and I'm going to change it to 4n minus n squared. All I did is I switched the order around. That's all I did. Verify that. 4n went there, negative n squared went there. All I did is I changed the order around because I wanted my parentheses to repeat. And that's the only, if I want a 4 in front, that's the only way it's going to repeat. If I do that, if I have a 4, I can factor out an n out of both of those, right? So plus n. And redistribute, just double check. N times 4 is 4n. N times negative n is negative n squared. That works. So this factors into m squared plus n times 4 minus n. And to be honest, I really don't like the n in the end. So rather than using another piece of paper, I want to get it all in on the same one. Note that 4 minus n, if I pull out a negative 1, I can change the order and change the sign. Just double check that. Negative 1 times n is negative n. Negative 1 times negative 4 is 4. And remember, commutative property, you can switch it around. So I'm going to rewrite this 4 minus n as n minus 4 with a negative 1. And I'll put the negative 1 in front. You still have the m squared plus n. And now I've got n minus 4. And you don't even need the 1. You do need the negative sign. Either of these will work. I don't know which one Math Lab will take. I want to show you something other tricky they might try. Let's try this. What if they give you something like this? A minus 7b squared minus 8 times a minus 7b plus 16. Well, notice I've got something squared and I got something to the first power and something without. What if I say like x equals a minus 7b? So let's let x equal that. Then I can replace this with x and this with x. And I get x, and that's squared, minus 8 times x, and then plus 16. And when you go through and factor this, you'll get x minus 4 times x minus 4. At that point, plug the x back in. Now replace x with its value. X was a minus 7b, so I should have a minus 7b minus 4 and a minus 7b minus 4, or a minus 7b minus 4 squared. So MATLAB will throw you some problems like that. It is common to use the letter U when making substitutions. I used X here because that's what you're familiar with. Let me rewrite that and show, just illustrate it. A minus 7b squared minus 8 times a minus 7b plus 16. Now we let U equal a minus 7b. This becomes u squared minus 8u plus 16. And you factor it, you get u minus 4, u minus 4. And then be sure to replace it. Now you go, why U? Why the letter U? And here's a good reason, and I don't think I've ever explained this to a student. I don't think anyone ever explained it to me. But thinking about it right now, we rarely use U at all. In fact, you got to get up to like Calc 3 and stuff like that before you start using U for things. You might use it in Calc 2. So if we consistently use U for substitutions, the letter U for substitutions, it is easier to remember we have to replace U at the end. If you always use a U when you make a substitution like this, then if you have a U at the end, you know you didn't start with a U, change it back. Okay? In fact, they call this a U substitution or a U sub. This is common terminology in mathematics. If you say U sub to a mathematician, they know what you're talking about. You say it to an engineer, you say it to a physicist, you say it to someone that works with anything math related at all, any of the technical fields, they're going to know what a U substitution is or a U sub. Okay? There's just a few more forms I want you to see. I want you to, other things we can do. This video is already getting kind of long, but this is just a long section. So we looked at three terms. Three terms, we had ax squared plus bx plus c. This is a trinomial. And it's said to be in quadratic form. When we set it equal to 0, it's a quadratic equation. So this is quadratic in form. We did 4-term grouping. 4 terms, we used grouping. 3 terms, we did the table. What about 2 terms? Binomials. So binomial factoring. Now, you can only factor something if there's like an x squared in it. So let's look at things that have like an x squared. Like, so let's say we got x squared minus 9. If you have something like this, you can use the trinomial factoring if we put in b equals 0 or a plus 0x. So now I've got a equals 1, b equals 0, c equals -9. They need to multiply to -9 and add to 0. The only way 2 numbers add to 0, they have to be equal and opposite. The factors are equal but opposite. And we know 9 is either 1 times 9 or 3 times 3. One of these has to be a negative. I guess we could have done +1 and -9. But the middle one is the only one that adds a 0. And so this becomes, and since a equaled 1, we can jump straight to the case. Straight to the chase. We put x's in front. We use our shortcut. We throw a -3 in one and a +3 in the other. This should look a little bit familiar. We did this going the other way. In fact, I called this to you something before. This is the difference of squares. If you have a squared term minus a squared term, it equals the a, like a squared minus b squared. It equals a minus b times a plus b. Or you can put the plus b first. It doesn't matter here. For x squared minus 9, I can rewrite this as x like that squared minus 3 squared. And that makes my x a and my 3 b. So I put the a in the front, which is x, and I put the b at the end, which is 3, and I just use different signs in between. So pause it if you need it. Like, why don't you try 64 minus y squared. I'm going to assume you paused it. If you paused it, this is in the form 8 squared minus y squared. So 8 equals a, what b or y equals b. And if I want a minus b, a plus b, I gotta do 8 minus y and 8 plus y. MATLAB might take it that way. Hopefully it does. If it doesn't, they want the y's in front. And remember, we can pull out, when you got these in backwards order, we can change the sign by putting a -1 out front. So that turns into this. And just to put the y in front, I'm just going to change the order there, y plus 8. So these are same answer, different form. So the options you'll see that you can do something with. Difference of squares. This is for your binomials. Again, a squared minus b squared is a minus b and a plus b. If you have the sum of squares, addition, a squared plus b squared, this does not factor to a real solution. Later on in this semester, we're going to start looking at complex numbers, and it will come up then, okay? So those are your squared options. We can also have cubes, the difference of cubes and the sum of cubes. And the reason why I'm saying them together is they look almost identical. A cubed minus b cubed and a cubed plus b cubed. They both have an a and a b in the front. Whichever sign is here, put here. And then you're going to have an a squared and ab plus b squared like this. So, and whatever sign's here goes here. And use opposite sign here. So I had a negative there, I'm going to put a plus there. I had a positive here, I'm going to put a negative there. That's the factorization for it. A cubed minus b cubed equals a minus b times the quantity a squared plus ab plus b squared. Now, I don't know who came up with that. That's pretty clever to factor that out. It's quite possible they started with something on the right, and then when they multiplied it out, they saw this thing on the left, and they're like, wow, that might be a general formula. I'm not sure who came up with it. Now, I know it's a little bit trickier than the difference of squares. The difference of squares is simple pattern. It's a very simple pattern. These two are almost identical, and you just got to remember the signs in front match. So once you've memorized one, you've kind of memorized both. And this is not hard to memorize with flashcards. If you've never used flashcards, get index cards. Where are my index cards? Index cards. Write one thing on one side, like maybe put a cubed minus b cubed on one side. On the back side, put the answer, a minus b and a squared plus ab plus b squared. And then whenever you got some free time, just look at one side, go, I see a cubed minus b cubed. What is it? I think it's this. Check. And if you get it right, put it in one pile. If you get it wrong, put it in a different pile. And just keep going through them until you have them all memorized. This is a great way to learn complicated formulas in math. This is one of the easier formulas. It's one of the harder ones for algebra, okay? This is one of the harder formulas for algebra, but when you get to calculus, it gets a lot more complicated, okay? Just because there's a lot more formulas. They follow a lot of patterns in calculus, and so it's doable. But there's a lot more formulas there. So use some formulas here. Let's take a look at some examples. Like 64r squared minus 49. A 64 is 8 times 8, so that's an 8 squared, r squared. Remember, when we had the rules of exponents, if we had something like this, and you put the 2 inside, you distribute the square, it's going to look like that. So I can write that first one as 8r squared like that. And then 49 is 7 squared. So I'll put 7 squared like that. And now this looks like a squared minus b squared if a equals 8r and b equals 7. So I want a minus b, a plus b. I'll take those and plug them in. I get 8r minus 7 and 8r plus 7. Okay. Maybe a little more complicated. 169. Let's go with, now let's use x. X to the 6th power minus 144y squared. Now, if you see two terms like this and there's some squares, the powers are even, I can definitely, whatever this power is, if it's even, I can divide by 2 and put the 2 on the outside. 6 divided by 2 is 3. I can have an x cubed there. And this might be a y in here. And then if you don't know those values, just use your square root function on a calculator. Square root of 169 is 13. Square root of 144 is a gross. 144 is a gross. Square root is 12. So we've got 13x cubed there, 12y there. This looks like a squared minus b squared if a equals 13x cubed and b equals 12y. So I want a minus b, a plus b. I keep writing down the formulas repeatedly, so hopefully it helps you. And now wherever I see an a, I'm going to plug it in, and wherever I see a b, I'm going to plug it in. So 169 x to the 6th power minus 144y squared. I plug in a equals 13x cubed into both. And in both, I plug in 12y. And I use different signs between them. Math Lab likes to get even trickier on you. Trickier. X squared plus 18x plus 81 minus 25y squared. Note the y is only in one term. So try to make the rest a square. One term and it's y squared. So if I can make the rest into a square, try making the rest a square. If you go through and do your factorizations, a times c is 81, b is 18, you get 9 times 9. This factors into x plus 9 times x plus 9 minus 25y squared, which is x plus 9 squared, minus 25 is a perfect square also. We can make this 5y squared. Take a while and process that. Make sure you get that. Now this looks like a squared minus b squared. if a equals x plus 9 and b equals 5y. So a minus b, a plus b. I want x plus 9 in front of both. I want 5y at the end of both, and a minus and a plus. Passive gas for you. You're welcome. Too bad you're not in the room to enjoy it. Let's switch it up. Let's put the square, the funky square at the end. In fact, I want you to try this next one on your own. Try on your own. Hit pause after I put it up. We're going to do 4x squared minus y squared minus 10y minus 25. And I do want you to note, this might make this a little easier if you factor the negative out of everything at the end, which makes all of this positive. Try to factor from there. Hit pause and factor from there. Okay, I'll assume you did. You should get y plus 5 times y plus 5. And now this is a perfect square. That's y plus 5 squared. And 4x, we can write that as a perfect square if we do 2 squared. So I've got a squared minus b squared, 2x squared minus y plus 5 squared. So this is my a and this is my b. With that being y plus 5, I'm going to do this. I'm going to make some big parentheses. The 2x goes in front of both just fine. But since that's a y plus 5, let's write that in. When I put a minus and plus in, this minus hits both. So maybe put that y plus 5 in like that. So we distribute the minus sign, and we get 2x minus y minus 5 times 2x plus y plus 5. Just got a couple more pages. We're almost done with the section. I know it's been kind of long. This is a long section. In a day with a 2-hour class, I would do like part of it one day with the last section, R3. I would have done with R3 and then finished it up today. This is a longer video. Take breaks in it. In fact, I'm going to put take breaks in the title. So let's look at some cubes. So t cubed plus 1,000. I can write that as t to the 3rd power and 10 to the 3rd power. My calculator has an x cubed, and I don't know if you can see it. Let me see if I can get it close enough. Right above it, it says 3 with the square root symbol. That 3 square root symbol like that button means takes cube root. And that's a key. So the way you can find it is hit 1,000, maybe enter, and then hit shift. Oh, let's do the shift. I had to hit shift to get to the button above. It says cube root. I'll put in 1,000, and it gives me 10. Okay. And I'll show that again in another second on the next problem. So this is like A, and this is like B. And the formula for A cubed plus B cubed We have the same sign in the front, a plus b. This is an a squared, ab plus b squared like that. And we use an opposite sign here. And so I'm just going to do what it says. A was t cubed, and b is 10 cubed. So a is t, b is 10. I'm putting those in. I've got t squared minus t times 10 plus 10 squared. I'm just replacing the letters with exactly what they match up with. And now you don't want to leave that one like that. You want to clean it up. So I've got t plus 10. T times 10 is 10t. And we got the negative. 10 squared is 100. Let's make it a little more complicated. 125u to the 9th power minus 216b to the 12th power. All right, so when I see something like this, do the exponents divide by 2? That would be difference of squares. Divide by 3. Cubes. And they do. I could write this as 9 is divisible by 3 and 12 is divisible by 3. I could do that. So these make perfect cubes. This will be a u to the 3rd power cubed. And how do I get to 3? It's 9 divided by 3. And 12 divided by 3 is 4, so I'll put that there, and I got the cube out there. Question is, are these perfect cubes? If you make a table of cube values, it's actually easier to remember. Some of them come up often. And I know we did that list. We made a list of those a couple episodes ago. Let's take this cube root. 125 will give you 5. And the cube root of 216 is 6. So this is like a cubed minus b cubed. The formula, we have a and b in the front, a squared, and then ab plus b squared in the end. And we use the same sign in the first parentheses and the opposite sign in the second parentheses. So what is a here? A equals 5u cubed, and b is 6v to the 4th power. So 5u cubed minus 6v to the 4th power. A squared, I need to make sure the 5 gets squared too. So I'm going to put 5u cubed in parentheses when I square it. And then I've got 5u cubed times 6b to the 4th power. And then I need to add 6b to the 4th power squared. So we'll put that in parentheses. Now here I would pause, make sure I did that correct. Just pause and double check. I've got a is 5u cubed, that matches out. B is 6b to the 4th, that's correct. A squared should be 5u cubed squared, that's correct. That was A and that's B, and they're multiplied together, that's correct. And B was 6b to the 4th, so I need 6b to the 4th squared, that's correct. Now that I've done that, I'll clean it up some. 5u cubed minus 6b to the fourth power. That doesn't clean up. But the second one, 5 squared is 25. U cubed squared, remember when we got a power on the inside and a power on the outside, we multiply the powers. This is u to the sixth power. 5 times 6 is 30, so plus 30. And then the u's and b's are different, so I just have to list them both. U cubed, b to the fourth. And then I'll square the 6 is 36. And b to the fourth squared, I multiply the exponents, it's b to the 8. And that was 125 u to the 9th minus 216 b to the 12th. Factors into that. Okay. So, general strategy for factoring. General strategy for factoring. Step 1, look for a GCF. If it exists, factor it out. And then step 2, try to factor what remains. And to do that, let's count the terms. If you have 4 terms, option A is 4 terms. To do this one, we did it by grouping into pairs. If we add 3 terms, this is the ax squared plus bx plus c, or trinomial. So we're going to do trinomial factoring. That's where we do a times c and b, and go from there. If we have 2 terms, here's your options. We could have a squared minus b squared. That'll be a minus b, a plus b. I could have a cubed minus b cubed, and that's a minus b, a squared plus ab plus b squared. Or I could have a cubed plus b cubed, and that we have the plus in the first one and a minus in the second one. I want to make a note. If you can use difference of squares and cubes, do squares first. For example, x to the 6th minus y to the 6th. Do squares first, then do cubes. You can factor it twice. And I do want to just call out one other thing. You might need, this applies to any of those, you might need substitution, might need a u sub. use substitution. For example, 3x minus 2 squared plus 2 times 3x minus 2 minus 8. If I let u equal 3x minus 2, this becomes u squared plus 2u minus 8. And that one factors more also. Okay? Woo! Long section, right? Long section. That's it, though. That's it. There's more problems. If you've got questions, come to Zoom. During this COVID pandemic, I got lots of Zoom hours. They're on Canvas. You can see them. If you're watching this video afterwards, come after the pandemic and we're doing live classes. If I haven't, bring your questions to class. If I'm doing a flipped class approach, whatever the case may be, boom. Peace. Stop sharing it and we'll end the video. Take care, everybody.